All right, here we go. Complex numbers part 2. I skipped over the graph for now. I think I'll just let the book handle that. When you're adding and subtracting these, just treat the I as an X. Just treat it as a variable and combine like terms. That's all there is to it. For these right here, we recognize that 2 plus negative 3 is negative 1. I plus 3i is 4i. That's all there is to it. If you're subtracting them, make sure you distribute the negative sign through and you're good to go. So those should be pretty straightforward for us. It gets a little more difficult when we get into some multiplication. If we multiply, just remember the thing we had before, that I squared is the same as negative 1. If you hold that in place, then life is going to be pretty good. Let me skip over that one. Let me do this one. It becomes a foiling. If you have a complex number times a complex number, you foil this, 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 this. And what will you get when you do that? 5 times a negative 4 is a negative 20. 5 times a minus 3i is a minus 15i. Minus 7i times a minus 4 is plus 28i. And a minus 7i times a minus 3i is a positive 21i squared. And we can simplify because these are alike, giving you 13i. But look at this, two things. First of all, a complex number times a complex number should equal a complex number. And this is not a complex number form. But do you recognize this? This I squared, isn't that the same as negative 1? So really, this 21i squared becomes a minus 21, which can be combined together with a minus 20 to be a minus 41 plus 13i. So that should be our answer for these two complex numbers multiplied together. Wow, pretty cool. Again, that I squared becomes a negative 1. Now let's take a look at part C over here, because part C, something kind of interesting happens with part C. Let me foil these. First of all, do you recognize that they're conjugates? Let's foil these. We've got the first, outers, inners, lasts, and we have 2 times 2 is 4. 2 times a positive 3i is 6i. A negative 3i times 2 is a negative 6i. And a negative 3i times a positive 3i is a minus 9i squared. Well, look at that stuff. The I, the imaginary part, drops out. And so does this drop out. This I squared becomes a negative 1. Minus 9 times, that's negative 9 minus, and that's plus 9. That's 13. It's real. When you multiply two complex conjugates together, you get a real number. The imaginary part drops out. And that is so key to when you're dividing these. Because when you're dividing complex numbers, you can't have, this is just a square root. And as we'll learn in chapter 6, you can't, and maybe you learned before, you can't have square roots in denominators. So we need to figure out how to get rid of them. And furthermore, this is not simplest form. This can be reduced. So how do you get rid of this radical right there? Well, you get rid of that radical by multiplying by the conjugate. What is the conjugate of 3 minus 2i? 3 plus 2i. And 3 plus 2i. Okay, so now I can foil these out on top. And what I'll be left with is a plain number in the denominator, a real number, and then I can separate it using the Valentine heart, and you can see what the final answer is. I'm going to stop right there because the key has the rest of it. The whole important part is knowing why that is a 3 plus 2i divided by 3 plus 2i. All right, so then that takes us to, I'll let this stand, but how do we find imaginary solutions? How do we solve this? I can't graph it, I can't factor it, I can't do anything with it. The only thing I can do is quadratic formula. So that's what I'm going to do. First of all, I notice that there's a negative sign out front. I don't want a negative sign out front. I'm going to multiply both sides by negative 1. Basically switch the signs on everything. So this becomes x squared minus 4x The opposite of minus 5 is plus 5. The opposite of 0 is still 0. And now I have my A, B, and C. My A is 1, my B is negative 4, my C is 5. Let's do the quadratic formula. X equals negative, the opposite of B, plus or minus the square root of B squared minus 4AC divided by 2A. The opposite of negative 4 is 4, plus or minus negative 4 squared is 16. 4 times 1 is 4, times 5 is 20, minus 20, divided by 2. This becomes 4 plus or minus the square root of negative 4 over 2. Let's move this over here. Do you remember what the square root of negative 4 is? We saw it in an earlier video. The square root of a negative is an I. The square root of 4 is 2. This is 2I over 2. Let's Valentine heart this thing. And we end up getting 4 over 2 plus or minus 2I over 2. Each of those fractions reduces to 2 plus or minus I. My two answers that you cannot see because they're imaginary are 2 plus I and 2 minus I. A whole lot of other practical things to do with complex numbers, electrical engineering, fractals, solving equations, lots of great stuff. And you'll explore those later on as you continue in your math career, hopefully aspiring to become a worker in that big gray building. I'll see you.